If you have ever wanted a public policy system to be driven by decades of economic data, personalized to your specific preferences, transparent across partisan lines, and collaborative down to the milliseconds, this is a session for you. Good morning, my name is Emily Weber, and this is a to-be open-sourced research project. So public policy has unique challenges. Let's understand what these are. First, in public policy, we understand that there's structural inefficiency, right? Particularly in the United States, where the groups of government are actually designed to slow down decision-making, right? This was a core feature of some of the early days of the US Constitution, right? But we also understand that there is actually a lack of a single clear goal, right? This is also a benefit of democratic processes where individuals actually regularly debate about what the final goal of public policy itself should be. It's also very challenging to synthesize information, right? When you're looking at data across many different sources, but not just different sources, different methods, different policies, putting all these pieces together is challenging. And additionally, the leadership turnover, right, particularly in countries where individuals are voted in and out every 4 to 8 years, is challenging, right? Imagine developing then executing upon a long-term vision in this context, right? And so what if we actually use machine learning to optimize public policy? So first, let's talk through our assets, right? Because on the one hand, we have decades of economic data that is available, particularly in the States. This is all just available from the census, right? There's a large volume of data that we can use totally for free. There's also, recently coming out, normalized policy data. And so this is currently coming from Amherst, right? Political scientists out over in the Northeast put together a normalized policy data set that actually compares policies across different states in the US. So you can look at healthcare, education, transportation, et cetera, and see how that policy was implemented in different states. And then lastly, if we think about what we would want our system to be, right, we're looking for something that is personalized, that can actually reflect the individual, perspectives of each person, collaborative and transparent. And then lastly, we want to wrap this in reinforcement learning, right? Reinforcement learning is showing potential to be intelligent, but also to actually model some of these mechanisms here. And so we also want to know that data-driven public policy analysis is not new. Right, so I come from the School of Economics out in Chicago, where we think about this a lot, right? And this question is usually causal inference, where we're going to take our data and we're going to break our data into what's called a treatment and a control group, right? Essentially, this is randomized control trial analysis, where we're going to look at, for example, the state of Illinois, compare it to the state of New York. But then you'll notice that after some policy was implemented in the state of Illinois, the levels in Illinois actually jumped, right? And so what we're going to do in the metrics world is run a regression. Right, so we're going to pull a regression here, and in particular, we're going to look at that beta sub t, and then we're going to make an argument about whether or not that policy was impactful, whether or not it actually caused a change in those levels. And now, in the machine learning world, right, obviously we're going to start with our use case. We're going to take our models and our data and plug those together. But in the case of reinforcement learning, it's similar, but slightly different. And the difference here is that rather than learning from just the data in the model, we want to learn from actions and rewards, right? Our RL agent is actually going to be actively taking different actions, and based on its action, it's going to go into a different state. And then based on that state, it's going to get a different reward. And so that's really how the learning happens. And mathematically speaking, right, if we break this all the way down, so we need some utility per state, right? We're going to be using the Bellman equation here for some dynamic programming. And so that utility per state is going to be equal to that reward function. And that reward function is a real number. So when you're setting up your own RL system, you need to figure out what your reward number is going to be. And that's part of the challenge. But then that's going to be equal to some reward function plus a discount factor, so you can take into account time. Then we're going to loop through adjacent states. Right, so that's that S prime there. And so for each adjacent state, we're going to get the transition value, then actually make a recursive call on that adjacent state, right? And so that's how it's going to actually populate this entire map. And so what we actually worked on was running thousands of randomized control trials across the United States. And so for each state in the US, we compared it with states across the country. But the first thing you have to do in that case is determine whether or not it's even valid to run a randomized control trial. Typically in econ, what we do is both use metrics, right? So we'll use something called a t-test, right? Pretty standard test there. But additionally, we also need to use logical reasoning, right? You actually need to think through what the causes were, what the levels were, if they're similar or not. And so eventually, we'd love to actually scale that out using data labeled by economists, right? So then we'd actually be able to have a binary model that's telling us whether or not an experiment itself is valid. After that, so we feed those results into an RL agent. The RL agent was actually named Pareto, after an Italian economist. And so Pareto is a deep learning model. Right? Pareto is a deep learning model that maps the economic variables to a policy suggestion. So the deep learning model itself is recommending a new policy. After that, a simulator is going to pick treatment and control states and then actually run a regression. That's an offline regression that we previously ran. So we're going to pull those regression results out. After that, we estimate the effect of the policy, but then we use that as the reward signal. So the effect of the policy is the signal that's training the RL agent. On top of that, we actually scaled the reward function itself by the validity of the experiment. So if an experiment was more valid, Pareto would learn more, less so. But a challenging question is actually figuring out the right way to optimize. And so in order to figure that out, we actually need to drop down all the way to philosophical foundations that underpin public policy analysis itself. Right, so just to cruise through these here, so there are 4 different types, right? If you're thinking about utilitarianism, you care the most about maximizing personal value across your entire population. In the case of egalitarianism, you want to make things most equal. In the case of Kantian rights, you want to uphold universal rights. In the case of libertarianism, you care about personal freedom. And so Pareto suggested, improving at least one person without making anyone else worse off. And so in reality, there is no single best optimization strategy, but what we can do is use data to automatically suggest policies based on user-defined preferences. And so the next slide I'm about to show you is still just an idea, but it's an awesome idea. And so what if we could do this, right? What if we could actually input our public policy preferences at the philosophical level into something that can then combine them? And then we can actually say what we think impacts public policies the most, and then recommend experiments based on that. And then we can actually determine the impact of those policies. Determining the impact of a policy is a very challenging topic, and so it's something that needs to be done with a lot of care, but then obviously communicating with elected officials would be great, and then being able to recommend policies. And something else that I'm also excited about would be the potential to see public policy from someone else's point of view. Right, because today we live in social media echo chambers, right, where we're constantly having our own views reinforced by people that we work with. And so what if you could actually switch and think about a policy from someone else's point of view? Pretty exciting, right? But then when you think about it technically, it's actually not too bad, right? Let's loop through the philosophical frameworks, right? So let's think about each of those philosophical frameworks as its own entity, and then for that entity, we just need to define the utility function, we need to update the data set, and then train a model. And so, for example, what if we thought about how to apply this framework when handling air traffic delays? Right, air traffic control is something that impacts probably everyone in this room. Right, if you took a plane to get here, then you were impacted by air traffic in some capacity. And I live in Chicago, where air traffic delays happen constantly. And so I'm always thinking about the best way to do this. And so if we think about how we would do this, we would look at those 4 philosophical foundations and then consider them. Right, so from the utilitarian point of view, where we're trying to increase overall utility, right, the first thing we would think about is understanding that different people value timeliness differently. And so we need multiple ways of defining utility for diverse stakeholders. And eventually, we'd actually want to use testing and surveys to get a numerical estimate for defining how different people value certain outcomes. In the case of egalitarianism, right, what we're going to do is try to basically treat everyone the same, right? Treat every airliner, every person exactly the same, versus in the case of Kantian rights, where we want to uphold human rights, want to uphold the sanctity of human travelers, make reasonable attempts to avoid delays. And then in the case of libertarianism, we want to preserve freedom, right? So we're going to preserve the individual ability for people to pick for themselves, potentially letting travelers switch, across multiple areas. And so there is fundamental overlap between the philosophical frameworks, but what I'm saying is that we can actually scale that reward, or we can scale that difference by reward functions, right? And so what I think we need is a computational system that can synthesize different points of view, that can weight those points of view on criteria, things like population size, something that can be transparent, collaborative, timely, and that can actually update with the times to efficiently support existing government bodies. And so with that, thank you very much. Again, this is a to-be open source research project. If you think this is really exciting and want to help out, go ahead and shoot me an email at effective-policies@amazon.com. Would love to collaborate and understand what other perspectives are out there as we put this system together. Thank you very much.